Hey, it's David. In class we did a problem where there was a charged ring and you had a point P above the center of that ring and you're trying to figure out the electric field on that point P, and I'm about to explain that. You're given these three equations, and this is what I always started out with. This is what I started out with the last video, which I'd recommend watching if you haven't already. And there's corresponding 3D, 2D, and 1D for each equation. It just goes across. So this 3D applies to this, 2D, basic algebra to get here, and then you differentiate both sides to get these equations. Obviously you can see how you got it. So here's the picture, and you're given Z and R. You're given how high point P is above the ring, which is Z. So I should probably label that Z. So it's a distance Z above it, and the radius of the circle is given R. I labeled this from point P to the edge of the circle as little r. That's just me labeling it. It can be whatever you want. It's not given, so you just need to remember that in your final answer. You don't want a little r. You want it in terms of capital R and Z, because that's the only things that are given. Okay. I redrew the triangle right here just to get a visual picture for later. And so now we're going to actually start solving it. So you're given this equation right here, and if you don't recognize that, you're in trouble and you need to go back and read. And so from that, you are finding the integral of k dq over r squared. Basically, that's just because if you take up an infinitesimally small point on this and you figure out the electric field due to here and you add them all up, it's the same thing as saying the integral of that. And you have the cosine of this angle, and I just notated it as in the j direction, just because remember, whenever you have this point and this point, the horizontal components are going to cancel out because they're equidistant, and so the only thing that'll be left is the j component. So it's the cosine of the angle in the j direction. That's what I notated that as. So this dq goes to this symbol times dl. I don't know the name of this symbol, so it's just that. That's just from this equation up here. And then this came from the cosine of the angle, and that's just because, basic trigonometry, adjacent over hypotenuse, adjacent z, you want this in terms of the given capital R and Z, so that's just Pythagorean's theorem, a squared plus b squared equals c squared. So you square root that squared plus that squared. Anyway, I just smush them together here, and this dl goes to 2 pi r, just because it's the length of this circle. Then from here you take this sign and it goes to QL from these equations up here. And this L and this 2 pi r are the same thing, because if you take this and you unwind it, it'll be 2 pi r, and 2 pi r is the circumference of this. So remember, this isn't a disk, it's just a wire that's charged, it's a ring. So this 2 pi r and the length are going to be the same thing. Use 2 pi r because it's the length, 2 pi r, same thing. They cancel out. K q z over r squared plus z squared to the 3/2, and that equals E. Okay, so that's the end of the video. I'm going to say one more thing just for the calculus people if you want to know one more thing. So if you think you're going to get confused by the calculus, then don't worry about it. So that's the end of the video for if you don't want to get confused. That's basically how you do it. For the calculus people, if you're wondering why this L is equal to 2 pi r, which is equal to dl, because usually you don't think dl is the same thing as L, it's just because all of these things are constants. All of these variables, all of these letters are all constants. So you could basically say E is equal to the integral of dl. So you could basically pull this all out because it's all multiplied. So you could pull it all out and rewrite it as E whatever you just pulled out to the integral of dl, or the integral of 1 dl. And when you integrate 1 to the dl, you just get length. And the length of this is 2 pi r. So that's how you got this, because you're not integrating k or this or this. They're all constants, they're not variables, so you don't have to add l's to each of them. You only add l to dl because it's the same thing as integral of 1 dl. So it just gets L. So the integral of dl equals L equals 2 pi r, and that's how you got 2 pi r is equal to L is equal to integral of dl. That's it.